Hello everyone. So today we are going to discuss this one numerical using the k nearest neighbor classifier. Okay. So this numerical is given in the course Introduction to Machine Learning by NPTEL from the week 1 assignment. So here consider the following data set with three classes 0, 1 and 2. Okay. Then there are this x1 and x2, two independent feature values or variables are given, whereas this y value is the class level. Okay. Using k nearest neighbor classifier with k value equal to 5, that means 5 nearest neighbor we need to consider while predicting the class of this new data point x1 x2 1 comma 1. Okay. And to find out the nearness between this new data point with the given data points in the data set, we need to consider the Euclidean distance measure. Okay. So let us begin it. So let me just extend this particular table with the Euclidean distance value. Okay. So what is the formula of Euclidean distance? Again, it is x1. Suppose if I consider 2t feature space. Okay, because here two feature values are given as well as two feature values are given in the data set. So this x1 is the like a feature value in the data set. Then let me consider this x1 new. Okay, just I am renaming it as x1 new whole square plus the second feature value that is given x2, then the second feature value from the new data point. Okay. So this is the equation to find out the Euclidean distance between the new data point with the existing data points in the data set. Okay. So here by following this formula for the first data point, if I calculate the Euclidean distance, then the value will be what? The first data point x1 value is -1 and the new data point x1 value is what? It is 1. So -1 whole square plus then the x2 value. This x2 value of the existing data point is 1 for the first row, right? 1 minus x2, the new data point value, the x2 feature of the new data point value is again 1. So 1 minus 1 whole square. Okay. So if we calculate this value, then we get what? This is -2 whole square, then this one plus 0, right, whole square, which is equal to nothing but 4 equal to 2. Correct. So the Euclidean distance value for the first data point from this particular new data point to the first data point is 2. Okay. Similarly, we will be calculating the Euclidean distance of the new data point from the second row of the data point, and this value after calculation is 2.24. Okay. So the calculation will follow using this formula only, which is a very simple formula, right? Then the with the third data point, this distance value is 3.61. Okay. And along for the with the fourth data point, this distance value is 1.41. With this fifth data point, this distance value is 1. Then the next data point also, this distance value is 1. Then with the next data point, it is 2.24. Okay. For the last data point, just for the again sake of the calculations, let me again show the calculation here. What is the x1 value for the data point? It is 2 what is the x1 value of the new data point? That is 1 minus 1, that's a whole square, plus the second data point of the existing data point is 0, and the second x2 feature value for the new data point is 1, so minus 1 whole square, which is equal to 2 minus 1 whole square, plus minus 1 whole square, which is again 1 square, right? So which is nothing but 1 plus 1, which is nothing but square root of 2, and square root of 2 is what? Square root of 2 is 1.41. So for the last data point, this Euclidean distance value is 1.41. Okay, so these are the Euclidean distance value. Now for finding out like which Euclidean distance value is the smallest one, which one is the largest one, like in some ascending order or in descending order, we can give one more attribute to identify that, and that attribute we can say as rank or the order. Okay, so what we will do, to the shortest distance we will give the rank, suppose 1. Okay, so here you can see for this data point the shortest distance is 1, right? This is 1, and even for the next one also it is 1, correct? So I can give the rank 1 to either of these two data point, okay, two distance value. Here when we see the y value, both the y value of these two closest distances are same, so there is no like way of any conflict here. If either of one we can give as rank 1, okay. But if the class level is different, then at that point giving this rank will affect the final result. Okay, so for that, which one we should choose, whether the first one which is coming in first order, that one we should give, or the next one, or if there is any more criteria, that will be already given in the question. But for this particular question, because I have to consider 5 nearest values, so the first two neighbor value it will not affect the result as such. Okay, so here let me just give to the first one only as rank 1 that I obtained in this table, and the second one Euclidean distance value I am giving rank 2. Okay, then which is the next smallest value here? Again we can see that this data point and these two data points, the Euclidean distance value with these both the data points are same from the new data point. But here one thing we can see that the class level, right, the class level for both the data points are different. Now at this point also, if suppose I need to consider only 3 nearest neighbor, then here it will slightly, it may affect the final classification accuracy. Although for this one, if I give the first one as the rank 3, then and if my k value is 3, then the class level, final class level for this new data point, for this new data point will be 1, correct? And if I don't give it 3, but I give 3 to this one, then I will consider first 3 neighbors as this one, and this one, right? So in that case, I have, out of the 3 nearest neighbor, I have one neighbor whose class level is different from the rest 2. Okay, so at this case also ultimately final result will not be affected, because the majority data points, what is the class level, that I will consider, right? But suppose if there is class level 2 here and I consider this one as the third rank, at that point the class level will be affected. Okay, but for those kind of conflict, if there arises any such kind of conflict, in the question itself the criteria will be given that which one we should choose. Okay, but luckily for this question I have to consider k equal to 5, so in this case it will not affect much, right? So just by following the traditional method where the data point which one I receive first, let me give 3 rank to this data point only, and this data point I am giving the rank 4. Okay, then the next data point which is the nearest one, I think is this one, right, 2. Then after this, again here this question is having so many conflicts here, right, so many so here 2.2524 here also, and the second last data point Euclidean distance is also 2.24, but because the second formed the first from the beginning, the second data point is I am going to rank 6, whereas the second last one I am going to rank 7. Is there any more data point left? This one is 3, right? Yes, this one is left, 3.61. So this was the farthest data point. Okay, so this is how we can add this attribute called rank or order, so that I can, like, by easily I can identify which one which data points are the nearest one, which are the farthest one. Okay, here for this particular data point, since I need to consider k equal to 5, right? So which Euclidean distance I am going to choose? This one, 2, then this one, 3, 4 and 5, this one, right? So I will see what are the class level, what are the majority class level for these given data points. These are the class levels, right? 1 and this one is 2. So the class level is for this new data point 1 comma 1, 1 is 0, then next there are 3 1 class levels and one data point which was nearby, the class level is 2. Okay, now out of all those I am going to consider which one is having the majority, or the mode I am going to consider whose data class level frequency is highest. So out of all these 5 class level, which class level is having majority count? That is class level 1, right? So this will be the class level for the new data point 1 comma 1 using the k nearest neighbor classifier by considering nearest 5 neighbors. Okay, thank you.